So I wanted to do a really short video about calculating the work done by gravity, and the main purpose of this video is to then show how we get to the idea of potential energy because of the result that we get. So in this scenario, it's really simple. We have an object, box, mass m, and we're going to lift it from some initial y position off the ground to a final y position off the ground. And so we know that the work in this case is a dot product of the force times the displacement. And so in this scenario, our force is the force of gravity. So that's minus mg, and I'm going to use the unit vector notation because it ends up being really friendly to use here. And then the displacement is just the difference between the two positions. It's the final minus the initial, and that displacement is in the positive j direction according to my picture. So when we do the calculation of the work, we substitute these in here. We have minus mg in the j hat direction, dotted with y final minus y initial in the j hat direction. And this is going to give us minus mg y final, because remember what we learned about the dot product of vectors written in unit vector form is the like components just multiply together. So when we take j dot j, that just gives us 1. And then we can multiply the mg times this and the mg times that term. And so then we also get plus mg y initial. So there's that sign difference here because the force was in the negative direction, and that's why we have a minus here and a plus here. And so now we start to look at it, and let's try to make some sense of this, because if you think about it, it's clearly an expression that only depends on the initial and the final position. In the expression for the work, there's nothing mentioned or nothing in here that really refers to what might have happened in between the two locations. We don't know what it did in between y initial and y final, but the answer ends up only depending on those two values. The other thing that I notice is there is specifically a y final and a y initial. And if I took out the negative sign, then I actually get two terms that look really similar, but they're evaluated at two different locations. So it's like, and this becomes sort of my final expression, and this is my initial expression. And so it really looks like I'm finding the change of something between the final and the initial, where that something would be the mgy. And that's where we start to get into the idea of like, well, the work could be expressed as some change in this quantity, because change always means final minus initial. And we call that quantity the gravitational potential energy. So if we say the gravitational potential energy can just be expressed as mgy, then this expression could just be equal to minus u final minus u initial. Get out of the way, Lynn. Or just minus the change in the gravitational potential energy. And so that's how we start to introduce the idea of potential energy, because the potential energy is something that is also changing when work is being done. The negative sign ends up having some significant consequence here when we think about it, because in the end, we're saying that the work is equal to minus the change here. The work done by gravity is equal to minus the change in the gravitational potential energy. And so we actually see that if the work done by gravity is a positive quantity, then the change in the gravitational potential energy has to be less than 0, and of course vice versa. If gravity does a negative amount of work, the change in the gravitational potential energy has to be positive. And so what we can see is that there's this definite relationship between the work done by gravity and this expression, this potential energy function. What does this mean? This means here, like if the work is done as positive, it means like as gravity is doing the work, then you have to think about like, well, we express that work in energy terms, so where does the energy come from? And now we can see that this is directly related to a decrease in the potential energy. So as work is done, the potential energy decreases. Or if the work done is negative, it actually results in an increase in potential energy. So it really is the idea of how the energy is flowing and how it is stored or used in a system. In the end, we start to think of potential energy can be thought of as stored energy, energy the system has based on where it is, because as you can see, that potential energy function depends on position. And so by having a different Y value, you have a different potential energy. And so I like using gravity to explain this and to sort of sort through this because we have a fairly good understanding of gravity. And hopefully this helps us to get a little bit more insight into this concept of potential energy.